Welcome and good afternoon at this last day of this year's Tech Days. And I see that the last ones are just coming in. You know, actually, I am glad that I made it on time. I love this venue. I really love. The rooms are fantastic. The AV technicians are fantastic. There's just this tiny little queuing problem they have in here. But I'm glad that we made it. So while the last ones are finding their seats, I'd just like to take the chance to point you to the download for the slides and, more important, for the demo material. I won't use too many slides. This is a session on debugging. Debugging doesn't work on PowerPoint. Code on PowerPoint always works. I've never had a bug in my PowerPoint-based code. So I'm not going to use too much PowerPoint. There will be only one slide, so it might not even be worth to download the slide deck in the first place. However, there will be a sample application, and you might want to get your hands on this sample application. If you've got any questions, I'll be around afterwards, of course. If you've got any questions later on, you can always shoot me an email to ingo.rammer@thinktexture.com. Now, as an advance warning, I've put this in the agenda for this session as well. This is one of the classic sessions. I've been talking about debugging in one way or another for about 5 years now. I think I talked about debugging in Visual Studio here in Belgium a few years ago. And of course, the session changes all the time because, well, I started with Visual Studio 2003, and now we have 2010. There are a lot more features, a lot of new features. However, if you've seen this session before, you know there's only about 15% change rate every year. So you might recognize some of these things already. Okay, especially the first part. Because when I'm talking about advanced debugging, what I'm going to show you is I'm going to show you debugging features in Visual Studio which go beyond what you normally know or what you normally use in debugging. The problem is debugging code should be easy. Well, in reality, it's not. There are a number of things which you can do when you write code to make your debugging easier, and then there are a number of features in Visual Studio which you can use at debugging time to make your life easier. And that's what this session is going to be about. Okay, I'll switch over to my demos now. Let me just see if I turn off Outlook. That's perfect. And if you've seen any of my debugging sessions, this might have been a totally different session because I do debugging not just in Visual Studio but also in WinDebug. Then you might have seen this application before. When you download this, you have to be aware of one thing. I call this the really buggy application. You know, in some sessions, people talk about best practices. This application is the contrary. That's the worst practice application. So you should never take code out of this application and copy and paste it into your application unless you want your application to break, which you might or might not. Now, behind all of these things, there are hidden bugs. For today's demo, I'm only using a small subset of these bugs, but I think they might be interesting. And if you want to examine more kinds of issues, etc., you have more bugs in this application for your pleasure and enjoyment to find them. Okay. Well, let's just make a sanity check here, if you're in the right session. Who knows what a breakpoint is? Who doesn't? 100% audience match. Perfect. Thank you very much. Sometimes 2 or 3 hands show at the I don't know what a breakpoint is. In this case, you know, marketing people, it's just not the right place for you in this session. I'm sorry. But here we have 100% audience match. That's perfect. I've never had this one before. Usually there are a few hands open. Okay. Now let's start our tour de force through Visual Studio debugging features. And I'm going to start very simple with a breakpoint. Now, well, everybody knows what a breakpoint is. Everybody knows we've just checked this. Everybody knows what this red mark means on the side. Let me just start a zoom in tool so that I can zoom. Okay. So we know the breakpoint. Now, the interesting thing is there are a number of things about breakpoints. There are things about breakpoints which I haven't known until very, very recently, maybe, 3 years ago, which meant I used Visual Studio for 7 years before even realizing this. Okay, so the first thing I'm going to show you is an option in Visual Studio which you might have to change, which has a profound effect on the way your debugging works. And this is Tools, Options, Debugging. So that's the standard. Everything we want to configure is here in Tools, Options, Debugging. And what I'd like to talk about first is Enable Just My Code. What does enable just my code mean? Well, by default, this checkbox is checked, which means that whatever you do will only affect your code. Why is this important? Well, because I'm going to disable this setting now. And as soon as you disable this setting, a few things change. So the first one is, if you go to the debug exceptions dialog, where you can set the exception flags, then you can see that you now have the option for thrown and user unhandled. User unhandled just means that, if only if you don't have a try-catch block, will the exception be shown. If you click thrown, of course, they will only be shown when they are thrown. We all know this. That's not an issue. The problem is if you go to Tools, Options, and disable this Just My Code setting, the Enable Just My Code, and if you disable this one, then the first and most obvious thing is that the dialog changes. So you have now only one option left, which is thrown. Why am I telling you this? Not because it's terribly important, but it's going to become terribly important because if you now set a checkbox to .NET exceptions, for example, and turn off this option again, if you turn off or if you switch back to enable just my code to the default option, and if you forget to uncheck this before changing this option, then this setting is going to remain set. However, you won't see it on the other dialog. The other dialog won't show you that you have checked it here, but your debugger is going to break on every hidden exception. So if you start your application from time to time and you notice weird exceptions creeping up, which shouldn't creep up because you have disabled just my code, well, they might creep up because you forgot to uncheck this before switching back this option to the default. But that's just for completeness sake. I've disabled this option now, and this allows me to do a few things. There's a dialog, which is the new breakpoint dialog. You can, if you use default key bindings, this is Control B, and there should be one here, debug new breakpoint, break at function. This would be the long way to do this. Now, usually we hardly ever use this. Normally, when you create a breakpoint, you click here or you use F9 or whatever your preferred key binding is. Control B is pretty magic. It allows you to set a breakpoint wherever you want. That is, let's say you debug your way through some code. You maybe use Reflector to get some understanding of how the framework works internally, and you figure out that you need to set a breakpoint on whatever console.writeline or XML serializer.writeline somewhere in the framework code. And you can use Control B to set a breakpoint wherever you want by just specifying the method name. So you can create a breakpoint on writeline. This will create a breakpoint on any writeline method in any object which is loaded or in any class which is loaded in your application. Use IntelliSense to verify something which you have to disable if you want to set it in framework code, because it might be an internal method for which you don't have IntelliSense information. So I'm just setting this to break on writeline. And I'm going to show the breakpoint window. And in here, you see a new symbol now. Oops, let me just zoom this. You see that this looks like a tree view now. This is what Microsoft calls a breakpoint group. The interesting thing is that this is not documented anywhere. A breakpoint group is something which is resolved at runtime. So if you would try to open it, well, I started my application before, but in reality, this is just a preview. In reality, this is handled at runtime. Whenever a new DLL is loaded, it will look at all classes, all methods, and try to set a breakpoint on writeline. So let me start this. And I'm breaking right now. Visual Studio is breaking, even though I'm not seeing the source line yet, because if we look at a call stack, you'll see that we are actually breaking in console.writeline itself. You're breaking on the first line of any method you want to. By just using Control B, method name, enter, that's the easiest way to set a breakpoint somewhere in some parts of code which are not your code. And of course, I can walk back in my call stack and go to the method which called whatever writeline it is. And if we expand the breakpoints window again, we'll now see that it indeed set breakpoints on a number of writeline methods, in XML writer, in text writer, etc., etc. So all the writeline methods are now triggering a breakpoint. What does this mean? Well, A, it means that it will slow down your application startup. If you turn on breakpoint group and forget to disable it, you sometimes have to wait for 5 seconds for your application to start. Why? Because whenever a DLL is loaded, Visual Studio has to examine all the different types, all the methods to find out if it should set a breakpoint or not. Second thing is, don't set a breakpoint on toString. Now, the interesting thing is I'm only saying this. I have never tried it. But you can try it. Now, the thing is, it gets slow because it has to set thousands of breakpoints, and this is just going to take a while because Visual Studio sets these breakpoints for you when you start the application dynamically at runtime. OK, so this was a breakpoint group. Next thing you can do with the breakpoint, and I'm just, as I said, if you have seen this session before, you know about these things, but I'm just going to bring us all on the same page here. The breakpoints have a number of different options. Some of them are good, some of them are bad. Now, I'm going to talk a bit about conditional breakpoints, about how Visual Studio offers you these conditional breakpoints, and about what you actually want to create instead of what Visual Studio offers you. So, but let's first go through the list of things you can do to a breakpoint. You can view its location. Well, oops, sorry. Do you see? Yeah. Let's see. OK, cable works again. I'm not touching it, I'm promising. The location is the location where your breakpoint is. It just tells you source line X. We don't need to look into this. We can define a condition. Breakpoint should only hit if a certain condition is true or false. It should only hit after a certain hit count. It should only hit on a certain thread. Personally, I've never used filter, which would allow you to set this on one thread. We might look into this, but in reality, you hardly ever use this. You can give it a name if you want to export them later on. And you can define what happens when this breakpoint is hit. I'm going to talk about this in a minute. But the important thing, the one which you really need during debugging, is the conditional breakpoint. Now, the conditional breakpoint sounds like a fantastic idea if you have code like the following. Let me just go here. Let's say we have a method like this calculateAll method here. And in calculateAll, I'm fetching a random number from somewhere, but just assume that this is not a random number, but you're parsing a file or whatever, or you're inserting a number of records. You iterate over all of them, you do something. And let's say you realize that you would need to have a breakpoint on the second to last element. Not on the first one, because there are 10,000 elements, but on the second to last element. That's what a conditional breakpoint has been thought for. So you can well, let's just first run the code without any breakpoint. I'm setting a breakpoint before the loop and after the loop, just so that you can get timing information, so that you can get a feel of how long the application usually takes to complete this loop. And I'm clicking on long calculation here. I'm hitting the first breakpoint, hit F5, hitting the second breakpoint. So the loop is really quick. Calculate 1 doesn't really do too much work here. OK, now let's assume that I want to break on the second to last element. I could go and set a breakpoint, and I choose condition. And in condition, you get a text box where you can specify a C# expression. In fact, it looks like a text box, but you get full IntelliSense here as well. So I can do if I equals number of elements minus 2. That's my condition. And I want to break if this is true. That's the first idea, the first step of going closer to this problem. And I hit OK. The symbol changes for the breakpoint to a plus now. And the plus tells you that there is additional information about this breakpoint. And let's run this code. And I'm setting a breakpoint here and here again, just so that we can again see what's happening. I click on it, I click continue, and now it's getting slow. Well, it's getting incredibly slow, and I need to talk for about 10 seconds or something, depending on what the random number ended up to be. Let me just break this now forcefully. I is now 2,700. Number of elements is 5,600, so we are only halfway through it. What's happening here? Well, a conditional breakpoint sounds like a good idea at the first glance. In reality, what's happening is whenever this loop is running, whenever the breakpoint is hit, your application will be stopped. Control will go back to Visual Studio. Visual Studio will look at the condition, will find out which values it has to pull from the client application, will take these values over, perform the condition math or calculate the condition, figure out if it should break, and if not, it will continue running. So that's taking a long time. So in theory, conditional breakpoints would be OK. In practice, they are hardly useful. So what's the next thing you could do? What is if we have to break like this? Well, One thing, and that's what I usually end up doing. I end up using conditional breakpoints if I cannot change the source code. Maybe because I'm attaching myself to a live server running in a live system and I can't redeploy this system. If I can redeploy the system, what I do instead is I tend to do things like, in real code, if I equals number of elements minus 2, debugger.break. So that's one of the things you can do. That's something which also you maybe shouldn't do in your real application, because it's a really bad thing if you forget to remove this code again. It's even worse than you think, actually. But let's just assume the easy case. Now, the easy case is we're clicking on long calculation, it breaks, fine. It's a lot faster. You've seen this instantaneously. If you really need to debug complex things, you can use debugger break and conditional logic to break whenever needed. Now, you should do a few things here. Problem is, if you run this if you ship this code, if you forget this code anywhere in your application, and you ship this code, and your client runs this code, your user runs the code, and let's close this down, and clicks on the same button, then your user won't be very happy about this. You know what, you can always say, yeah, but no problem, I'm not forgetting this, yeah? I will remove this. I promise you will forget it at some point in time. You know, it's just one statement somewhere. Okay, so you should actually not do this. What you should do instead, let me just kill my really buggy application first. And there is another check which you could do is if debugger is attached, debugger break. Even if you only intend to keep this in for 5 minutes, please always guard it using this statement, because otherwise you will forget it from one time, at least once. Okay, but this now checks, and only if there is a debugger will it break. So if you run this in Studio, run it, it breaks. If you run it outside of Studio, nothing happens. Everything is okay, the application continues running. Okay, that's important. Never run debugger break just like that. Okay, now let's remove this code again. Okay, what else can you do with a breakpoint? Well, you can use a breakpoint to give you first additional information about what's happening without really breaking your application. And that's this when hit option here. And in when hit, I think that's an underused function, an underused part of the breakpoint system in Visual Studio. You can define what happens when a breakpoint is hit. You can define to just print a message. And do you know how often you sometimes have to, follow call chains in different events? You have to find out in which sequence your events fire, on which threads your event fire. You can do all these using just a breakpoint and just checking this, because the default information will be function name, thread name, and you can already find out in which sequence your events are firing without putting in debug write-line statements or console write-line statements. And maybe even more powerful, you can run a macro. And there are some default macros with Visual Studio which use the debugger infrastructure, because your macro can do everything in Visual Studio. You can trigger a macro which sets another breakpoint, or which enables or disables another breakpoint. This allows you to create complex sequences of events. You can set a breakpoint here, and if this is hit 5 times, then you activate this other breakpoint, and similar things. You can automate your debugging in this way. You just need to invest a little bit in infrastructure up front, write, 10 lines of wrapper code once to make this work. Okay, these were the 2 features of the whole breakpoint infrastructure which I see as underused features. And debugger break is very helpful because it makes your life easier and faster. Okay, let's switch back to the slide just for a second so that I don't forget things I want to show you. Okay. Now, the next thing I'd like to show you has nothing to do with the breakpoint. It has to do with how data is shown in the watch window. And I've created a customer class for you which looks like this. It's just a simple data class. I just have a property name, a property first name, local variables which match this, property address of type address, and there's an address class with city and street. Okay. And let's just fill in some data. We have customer.first name is John, customer.no, not Hon, John, customer.last name is, customer.name is Doe, and customer address is a new address, and city is Antwerp, and customer address street is Metropolis. Okay, and I'll just break here so that we can look at this. Okay, let's run this, and the only thing I care about is my watch window, and I'll take the locals window for this. Okay, first one, oops, let me just resize this so that it's a little bit more readable. That's exactly what we expected. Nothing magic here. You're doing this on a day-by-day basis. That's exactly how an object looks like. So the thing is, there are a number of things which you can do to make life easier for somebody who is using your classes. And there is absolutely no reason that you don't do this. And I don't know why I'm not seeing this more often. So the problem is the following. If you have a customer like this, and I have a list of 10 customers, and I expand the list, the only thing I'm seeing is, yep, it's a customer. So I'm seeing 10 times the information that you have a customer in there. So I have to open each one if I'm hunting for a particular customer information, have to open each class, look at the data. And then there are a number of attributes which you can use to customize this. And I know that some of you might already know this, and some of you might already do this. But from past experience, I can tell you that about 50 or 60 or 70% in this room don't regularly do this for their classes. And it's really not much, because you can, so all these attributes, they are in system.component model, and there is one, no, it's in system.diagnostics, I think. And there is one which is called debugger display. And that's the first one. Debugger display, and I'll remove the namespace here. Debugger display allows you to specify how this type should look like in a debugger. And you can specify a string here, which can give you information. Name, first name, in address.city. So you can specify an expression here. This is only evaluated at runtime. Nothing breaks if you have null reference or anything. It will just tell you that you cannot evaluate this expression. It's very easy. As you've seen, there's no dependency, nothing. And I'll just rerun the code. And already now, I can see that you get better information. It doesn't look nice because it puts the strings in quotes, etc. But it makes life a lot easier, and just by writing one attribute. Okay, but the rest of the object still looks exactly the same. Everything here is still the same. So the next step could be that you say, you know what? Actually, the user of my class doesn't have to know how my privates look like. So I'd like to hide these private members here, so that they only see the publics they should be interested in, the public members. And you can do this using another attribute called debugger browsable. And you pass in a debugger browsable state, which could be never. Let me just move this over here. And this means hide this field in the watch window. And I'm hiding name, I'm hiding first name, I'm hiding the private address, I'm hiding the private city and the private street. And I'll rerun the code. And it looks a lot more, I don't know, readable now, because, I only care about these things. I don't care about the rest. Now, while you develop your software, you might care about the rest. So you can go to Tools, Options, Debugging again, and there is one option which is disabled by default, which is called Show Raw Structure of Objects in Variables. This means exactly what the name lets you think. It gives you the clear text view, the old view. Okay. And then, so up to here, these were two attributes where I say, well, at least especially the first one, debugger display, there is no particular reason for not using this. Because there's no side effect, no negative effect. Now, I'm showing you one, or I'm starting to go into areas where you could have negative effects if you're not very careful. And one of them is the following. You go to, let's just say that, you will always need to see the address of the customer, and you want to have information about let me just go into the watch window again, and you want to have oh, I removed the breakpoint. That's not a good idea. Yeah. And, you say, you know what, actually, I always care about the details of this class, and I'd like to show this in an easier-to-use way. And there's another attribute for this one, which, well, it's a subset of debugger browsable. And you can specify debugger browsable with the debugger browsable state root hidden. And root hidden means that you're now changing the way the object looks like. You are not showing this root class, you're not showing the address class, you only show the fields of this object. And now let's look at this one. Is this good? Well, this totally depends on your application. It might confuse your user more than it helps them, or it might help them more than it confuses them. It really depends. That's something which you have to decide whether or not this is a good thing or not. Now, there could be the case that you say, well, you know what, I'd like to have some kind of mixed view of this, or I'd like to have the object be represented in a debugger in a totally different way. Because, I have this internal data structure, which I don't want to show to the outside world. Let's say you're doing a linked list, but you want this to look like an array in the debugger, or things like this, because a linked list is not easy to use in the debugger. Then there is another option, and this is a debugger type proxy. So you can create a proxy for your class. So let's just say we have a customer proxy, and a debugger type proxy doesn't have to do anything special. You just usually keep the data somewhere in a private in your constructor, and that's the only requirement. In your constructor customer proxy, you take an instance of this data object, and I'll associate it to my internal customer. And now I can change the appearance. This can be used for good or for bad. And using it for bad means you can do things. You can do subtle things to your co-developers, like creating a property public string main instead of name, and you return name. You return customer.name, and you can have a public string nursed fame, which returns the customer's first name. And it's fun if you do this once. It's not really fun if you keep doing this. But if you have a new co-developer, somebody who's fresh from university or so, they need some kind of reality check treatment from time to time. So maybe this helps with their education. Let's call it an educational thing we're doing here. OK, we run this, and nope. Of course, nothing happens. I've just created another class. I need to associate this. And there are different ways to associate this. There's the nice way. The nice way means you put in an attribute onto your target class saying debugger type proxy, type of customer proxy. So you just put this onto your class and say, OK, instead of this class, always show that one. And nope. There is some typo somewhere. Let me just recheck this. Customer, it's class customer. We have a debugger type proxy of type customer proxy. Which is this one? We are setting this, and let me think. Did I check this? No, I didn't check show this. Let me just check. No, this still looks incorrect. Oh, that's pretty interesting. I've been doing this for I don't know how long, and as you might have noticed, by the speed in which I type and speak at the same time, that is not exactly the first time that I'm showing this, but it's the first time that it's not working the way it should. Public customer proxy, which is a regular class. If anyone notices this, please help me in here. We have a string which gives us something. We don't need a setter, so that's the thing. You can have get accessors. That's what people mostly do. You provide different get accessors to view some internals of your data structure in a different way. We set this one. It's set. It's here. Oh, now my microphone is completely dropping, I think. So let me just see. Is this more on your side or more on my side? That the microphone is dropping? Or is this? It is. No, it's OK now. OK. Because I think it just dropped for half a second or so. OK. No, I'm not trying to find a way out of this one now. No, that's just, you're implying something which is just not correct here. OK. I will jump over this now. I will swiftly glance over this error, which has happened now. It will bother me for ages, because I know that during the break, I will revisit this code, and I will immediately see what the problem is. And I need to find this. It can't be, right? Debugger type proxy. We have a type of customer proxy. Do I have another customer proxy somewhere? No, that's the customer proxy. Whatever. Normally, let's just assume, I'm just telling you what you are seeing now, so you have to believe me. It's like, I'm telling you a fairy tale thing. I'm just, a good friend telling you a story. And the story goes so that you would now see here a field which is not called name, it's called fame. It's not called first name, it's called nursed fame. However, you would see a raw data structure, a new item in here which you can expand, which gives you the original view of this object. So playing this trick on our just fresh from university student only works up to a certain point. And it works better for longer objects where they don't really scroll to the end. Works perfectly for those. You're not sure now if I ever did this, right? You're not sure if I could be that evil. But let's say I could, maybe I could. And then you would see the real structure of the object. Okay, I don't know why it's not working right now. I've literally done this maybe 20, 30, 50 times even at a demo scenario like this, and it used to work, but it doesn't anymore. But I'm not too bothered about this. Okay. Because I'm trying one more thing, which is even harder to do, and if this first one fails, then I really think that the second one might fail as well, because it might have exactly the same reason, which I don't know right now, but I'll still try it anyway. I can't, that's a very good question. Can I set a breakpoint? The thing is, unfortunately not. This runs inside of the Visual Studio context, so you can't really set a breakpoint on it as well. But let's try something different. Excuse me? I'm not instantiating, I'm just copying it. So I just get a customer from outside and just put it into a local field in here. That's how you'd normally do a debugger type proxy. You just put it into a local field. This is public, the class is public, it's called proxy. It is, I've referenced it down here, debugger type proxy. There is no particular reason why this could fail at this point in time. But this is a session about debugging. What would I normally do? That's the interesting thing. I can't do this right now because it's going to take about 5 minutes. But what would I normally do if this happened to me in real world? In real world, what I'd do is I'd go here, I'd do a debugger.break here. I'd attach a second Visual Studio instance to my first Visual Studio instance, and the second instance will trigger on this breakpoint, which is running inside of the Visual Studio context. This works fine, but it takes a bit too long. Okay. Instead, we up this, we go to the next level. The next level is a debugger visualizer. Now, given that the debugger type proxy, which can't fail, is already failing, I'm really looking forward to what's happening to my debugger visualizer. A customer visualizer would allow us to edit customer properties in a totally different way. Here we have to derive from from dialog debugger visualizer. There is one method which we have to implement. And let me just not implement the method for now, because I'll first try if it works at all. I don't trust my system anymore. I just put it on the Microsoft updates, which have been applied early morning today or something like this. Really, I started right before the session. 2 hours before the session, the computer decided that it needs a reboot. And debugger visualizer. And it then told me it needs to install 5 updates, and it went there, installing updates, 0% done, and it remained at 0% for about 15 minutes. It told me, don't turn me off. I did turn it off after all. It's still rebooted, that's a good thing. So whatever happens, I'm going to put this down to this update, I'm telling you. Okay, we only have a visualizer here, and let's run this again. There were build errors, that's not a good thing. That's true. Let's just, I've already created a visualizer before. This could absolutely be the case that I've created a visualizer before somewhere. And let's just get rid of this visualizer. Just commenting out some old code. And, but this could be the case. There's old code running in here as well. There's new debugger visualizers. Aha, there you go. I should have cleaned this application more thoroughly. Okay, so after we register a debugger visualizer, and interesting enough, for whatever reason, this works. You get the magnifying glass icon here. That's the same thing you get for strings, for example. If you just expand this, there's a string in here, and for every string, you get the same magnifying glass. And if you click it, a dialog box opens. And that's just a regular debugger visualizer. That's just the same thing you are creating here. And creating this is also just a few lines of code. In your debugger visualizer, you get a Windows service and an object provider. So basically, what you can do is you can look at the element which the user has clicked on. And in my case, I'm just doing a customer. Cust is object provider dot get object. and then you'll get the object. You can manipulate it. Of course, I have to cast it to customer. And after casting it to customer, I can manipulate it. Now, normally you would show a Windows form, because that's still Windows Forms-based architecture. So you would create your form1 FRM is new form1. And then you would not do frm.show. This wouldn't work, because you have to show it inside of Visual Studio. So instead of doing form1.show, you would do a Windows service. That's the second or the first parameter you get. Windows service show dialog FRM. Then Visual Studio would modally show your dialog. As soon as the user clicks OK, you can then change the object. In my case, I just changed customer.firstname to Martin, and then you return it back to Visual Studio by doing object provider replace object. No, not replace data, replace object customer. And let's just run this. And instead of doing this Windows service, I'm just creating a message box now. Message box dot no message box, yes message box dot show. Now something happens. But just so you can imagine that I'm showing a dialog now, but given that I can't even create a type proxy, I'm not going to even bother doing a Windows form now. You wouldn't believe me at all if I even try to do this. Okay, so I'm clicking here. No. Haha, but this really explains it, does it? It's a dialog debug. No, it doesn't explain it. But it's the same source. That's interesting. Let me do You know, the thing is, I'm just so extremely, absolutely glad that I'm doing conference sessions like this so often. If I would be a beginner, just imagine that I would be here and this would be my first session ever. You have never seen me before. You haven't seen anything I've ever done before. And then things like these would happen. You would kill me. Half of the room would have left, and I would have totally deserved it. Yesterday evening, I spoke with another speaker about preparing before a session and about the fact that it shows a lot of disrespect of you if a speaker doesn't prepare explicitly, because I am wasting 650, or in this case, 350 people's time now. And that's really embarrassing for me, because I do prepare a lot. I've done this particular session 30 times, and there is absolutely no reason why this should fail. So I'm really sorry, and I know that during the break, I'm going to find this out. Okay. But we can again, no, you know what the problem is? The problem is that I'm doing live coding here. And before doing this session, I have to clean my project from all the changes which I did before, and I must have forgotten to clean something. Now the problem is, I've created so many visualizers in this project, debugger type visualizer. Let's just look for them. Maybe we can find one. Oops. Debugger type visualizer. But these are different. These are visualizers for different things. So there's really no particular reason. There is one. No way. Wait, I found. So let's try one thing, okay? Now, because I forgot to tell you something which you need to know anyway, and nice, huh? You have to set a reference, and that's my problem. And I know now what the problem is. That's good. You need to reference Microsoft.visualstudio.debugger visualizers. And that's a Visual Studio version-dependent assembly. And I am 100% convinced now that for whatever reason, this is pointing to an incorrect version of Visual Studio. And that's why it cannot cast this. The message box we've seen now, this actually shows us this. So this tells us that it cannot cast my customer visualizer to dialog debugger visualizer, even though we know that it's a dialog debugger visualizer, because that's my base class. That's the base class I've put there. However, that's not the right base class, because it's coming from a different assembly. I don't know what has changed these assemblies, because literally I have done this demo on this very machine before. So maybe I install a Visual Studio Service Pack or whatever. I need to fix this later on. I did not replay this particular part of the demo before this session, because I've done it 30 times. However, I did obviously do something to my system. But that's the reason. And that's also good for you, because this might happen to you in the exactly same way as it happens to me here. The reason is that this particular DLL is now in the wrong version. And if we look into this, then I'm sure it's not referencing the right one in the Visual Studio installation directory, but some other version. And it uses an older version of this DLL. OK, this explains a lot. Now, I'm not going to fix this now. You just have to believe me. You have to reference the Dev 10 version, not the Dev 9 version, if you want to run your code in Dev 10. I have no idea how it can switch back from a working Dev 10 version to a not working Dev 9 version, but we are never going to find this one out. Okay, but normally you'd get your dialog now. Okay, and this means we can switch to more important topics than watching Ingo breaking in sweat and trying to find a problem which cannot exist. Oh, that's good. Okay. So what else can we do? Let's see. There are a number of new options now. A few of them from Visual Studio 8 and most of them from Visual Studio 2010. And there are some in debugging, which some of you might have seen, some of you might not have seen. There is one which is quite interesting, which is Enable.NET Framework source stepping. This allows you to download the source code of the .NET Framework from Microsoft behind the scenes, and you can just F11, you can just step into framework code in this way. So that's something which is very nice, which is usable, or actually quite useful even from time to time. Let me just switch back. What else I want to show you? Well, there are a number of interesting things inside of Visual Studio 10. If you use Team Foundation Server, you can get even more advantage of this. Now, there are features which at first glance look interesting, but they are quite nice, well, interesting in terms of yeah, that's possible, but what do I do with it? But on the second glance, there are some things which are quite interesting, especially if you combine it with custom macro programming to actually do something with this data. Okay. Let's assume that you are hunting a bug. You got a bug report. You're finding this bug. You're trying to follow the repro steps, and you come to a point where you say, you know what? I'm nearly about to find this bug. And you suddenly realize that it's not in your code, it's in your co-developer's code. And there are 3 different tools in Visual Studio which you can use to make it easier for your co-developer to find out what you have found out or to transfer information to them. One of them, and that's the easiest one, is the pinning of data points. They're called pinned data tips. So I can pin this address field here, for example, and out of the address I can pin the city, and this is pinned into the source code. So this moves with the source code. If I stop the debugging cycle, and if I restart my debugging cycle, they will reappear at this position. So you can again see what you've put in here, and you can put a comment here. So you can say, I think this is really wrong. Maybe you have used the wrong DLL inside of Visual Studio. Okay, so you can put comments like these in here, and then you can export these. You can export data tips. You can export a whole collection of data tips, the one which you set into your code to annotate the problem you're currently finding out about or finding out more about, so that you can export this and move this to a colleague. To export them, you can go to debug, export data tips, and on the other side, you can import them again. And again, you can automate this using macros. If you have some process, or you can automate these to include even your Team Foundation environment. So that's one thing you can do. The next thing, which is absolutely non-obvious, is with Visual Studio 2010, you can save and restore breakpoints independent from your SUO file, the user file, and just export them into an XML file and re-import them. Again, this allows you to transfer your breakpoint set or a certain set of breakpoints to a co-developer. So you can right-click and you can export selected. And as I said before, you can edit a label. You can give this breakpoint a name. You can say, this is where the thing is going wrong. Bug 1978, whatever. And then you export selected into an XML file. And your co-developer can import your data tips and your breakpoints and can continue debugging from this point on. Okay, so that's one of the things. Now, the next thing is IntelliTrace. Now, IntelliTrace is different from everything else I'm going to show you throughout this session. It's magic. IntelliTrace is pure magic. It has one big disadvantage. It comes only with the Ultimate edition of Visual Studio. All the other tools which I'm showing you are available with every edition. Well, maybe not Express, but with all real editions. And I don't know if they are part of Express. I've never run Express. So I can only say that, I think that they are maybe not part of Express. Maybe they are. Okay. But IntelliTrace is definitely not part of Express. But IntelliTrace is a fantastic tool. So let's just start IntelliTrace. And let's say what we can do IntelliTrace on our long-running calculation. let's see, where is it? It's in total value calculation in here. And let's just assume something could go wrong in, I don't know, if I equals number of elements minus 10, then throw new exception, foo. And we'll just throw this exception, and we just assume that something is going wrong like this. Okay, so I'll enable IntelliTrace. Tools, options, debugger general, and our IntelliTrace is over here. So it's not debug, it's IntelliTrace. And you can then enable it and define if you want events or events and call information. Now, IntelliTrace is a black box recorder. It records everything which happens to your application. This is fantastic. You can enable IntelliTrace, and for both options, IntelliTrace and call information, and run it. And now IntelliTrace slows down your application while it's running, because it's storing a lot of information in a ring buffer. So I can go ahead and I can go to my long calculation, and of course I get my exception. But what IntelliTrace gives me is I can look into an IntelliTrace window, and IntelliTrace shows me shows me the past. It shows me what happened to my application. For example, if I did more, I didn't do too much, but if I did more than just clicking the one button, it would show me which gestures have happened. So it shows me which buttons the user clicked to achieve the point or to reach this point where the user is, or the tester is. So I can then go there and can switch into a calls view to find out what happened after this. Again, this now looks like a call stack, but that's not a call stack. That's a historical view of what happened. So let me just go there. I'm just going to take a few steps down so that we can see this. And this looks like a call stack, but it's not. And I'm just moving this a little bit smaller so that we can no, we can't. Okay. It's not a call stack, but it's a historical view of call stacks, because it tells you that, calculate one has been called with this property, and then calculate one has been called with another value, etc., etc. So you can go back in history. And in each point of this history, you can, again, go into each method which has been called in the history. And you can view how locals looked like back then, even though you changed this. Even if you have a global variable which you've changed multiple times, you'll see them in the history in IntelliTrace. Now, IntelliTrace, the only thing I don't like about IntelliTrace is the licensing, as I've mentioned. It's only part of Ultimate and of the test edition, and that's one of the use cases. If you have a test department which uses the test edition of Visual Studio, they can run IntelliTrace, and there is a command line option for IntelliTrace. So let me see if I've got this one installed here. I'm not 100% sure, but let me open this one, and there's trace. But I don't trust my system anymore. You see, I'm getting more defensive over time. I can run the application in trace. That's just a batch file which you can write to start your application inside of IntelliTrace and cause the same problem. We do long calculation. Of course, the application closes down. We just say continue, and then we end the application. IntelliTrace is now writing this trace file, which you can double-click, open inside of Visual Studio, and you see the different threads here. You pick one thread, and then you can see what happened on this thread when your tester ran this application, or when your tester ran this particular test case. So you have your repro steps, not in textual form, but in clickable form. You can walk through the things your tester did. That's fantastic. That's really, I would hope that at some point in time, Microsoft puts this into the professional version so that every developer can use this. But for now, it's not. But especially in the test use case, it might be worth the investment because it allows you to repro your test cases on a step-by-step basis. Okay. The next thing is, again, part of your edition of Visual Studio, and you don't need to have Ultimate for this. And this is pure magic. Again, I'm not even getting money from Microsoft for selling Visual Studio here. In fact, I'm not even selling Studio. The thing you're seeing right now is part of the Studio you already have. That's a good thing. And that's crash dump debugging. So I'm compiling this application, and I'll start it outside of Visual Studio. And in the past, Well, if you look at crash dump debugging, who could do crash dump debugging? Well, C++ developers or C unmanaged code developers, they could do crash dump debugging for ages, for years. Inside of C# or the .NET environment, you could do it using WinDebug and SOS. These are low-level tools. I love them, but I spend way too much time with them. And for me, these tools are essential. But I do a lot of debugging of applications where I have never seen the code before. That's what WinDebug allows you to do. But that's not what most developers I know actually want to do on a day-to-day basis. But what you want to do is to still be able to find out source causes for problems which happen at your client's machines. And that's what this feature is about. It's about creating a crash dump or a memory dump at your client's machine when the application crashes or shows an error or something. Your user then takes this crash dump, the DMP file, sends it over to you. You can open it inside of Visual Studio, and you can see how the application looked like when the crash happened or when this exception happened. Not just the exception stack trace, but everything, all local variables, everything. Okay, so let's just assume the following. You have an application, you click on Do Work, and your user calls you because your application says that it can't do work. That's not very helpful for anyone. In a lot of cases, if you don't do crash dump debugging, what you'd now do is maybe go back to your office, create a new debug build, send it to your user, and so that they can run the new debug build so that you get more log information or things like these. With crash dump debugging, the thing could be changed. You could create an application so that it automatically writes a crash dump when an exception happens. And that's what I've done here. I'm creating a crash dump on disk. It's this DMP file. Now, I'm shutting down my application. I've not been running this inside of Visual Studio. That's important. I just clicked on the application, started it. I'm now right-clicking the dump file, and I choose Open in Visual Studio 2010. And now that's a new feature of .NET 4 and Visual Studio 2010. Not the fact that it's loading user settings. That's some annoying feature which we don't know where it comes from, but the fact that you can open these dump files. Okay, so let's wait a second. And after this, you can do something which in a previous life only C++ developer could do. You could open a dump file and view it in Visual Studio, correlated with your source code. And to do this, you have to go over here and you have to click on Debug with Mixed. That's new. In the past, you would only have the native option. But debugging with Mixed gives you a source line information of where your application was. Now, that's the line of code which I use to create this dump. That's just an API call. Minidump write dump is a Windows API, which allows me to create a dump file from a running process. But I can go into my call stack, and I can move back in the call stack. And let's say there was a method called not so helpful error, which I called. It tried to do some work, and then I caught the exception. And in my exception handler, I delete the file if it exists, and if it, I remove it, and then I call create minidump to write this dump file. And you don't need to be an administrator for this. You know, on Windows, you only need to have administrative privileges if you debug another user's application. But if you debug an application which runs in your space, using your credentials, you can just create a dump or debug the application without being an administrator. So this works no matter which context you're using. So I'm just creating this file. Of course, the user has to be able to write into this directory. That's obvious. And but you could also do this in a global exception handler, in whatever way, using the app domains exception handling method or your Windows Forms or your WPF's exception handling method, and to create this exception, this dump file. And in the dump file, if we go back a bit, you have all the locals. So let me just expand the locals. Or let me just show this. Nope, okay. So there are two kinds of dump files. And I want to show you both. So normally I show them in the other sequence. But in this case, it's okay. This dump file is 185 kilobytes in size. So that's really small. Of course, in this small version of the dump file, you don't get the complete view of the application. But there's a second option. You can create a dump file which is substantially bigger, but which contains all this additional information. And if you do this, or to do this, you just need to pass a different information to create minidump. And let's just stop the application. Let's just go there. and oops, mini dump, create dump. Oh, I'm here in not in my real code, but in the dump file, or in the code the dump file has loaded. So let me go back to dump writer. There should be a let's say mini dump write dump method somewhere. Yep. And in here you pass a dump type, and the dump type could be 0, or well, there are a number of different flags which you could or into your dump type. The really important dump type is dump type 6 on the .NET framework. Basically, 0 means only the least amount of information possible. You will get information about the call stack, about the exception. You will get information about each thread, so you can switch through the threads in Visual Studio, but you won't get locals. And if you use dump type 6, you'll get everything. And let me recompile this and rerun it. You have to run this outside of Visual Studio. Creating a dump does not work if you're running inside of Studio. So I'll just double-click the application again, click Do Work again, click OK, and let's look back at our dump file. This would be C dumps, and now the dump file is a lot bigger. It has 100 megabytes. And for a real application, if you look at a real Windows application, you usually think about something like 500 megs for a dump file. For a server-based application, it could be bigger. If you're looking at a 64-bit web application under high load, we're talking about something like 8 gig, 16 gig, depending on what the working set of your application is. So is this good or bad? Well, you can't really tell. It's simply the complete memory snapshot of your application. Yes, it is massively big, but it's highly compressible. You can compress this down to, let's say, 15 to 20% of the original size, and then your user can FTP this to you. Or if it's a web process, then you maybe have it on your own server anyway. But the thing you can do with it is massive, because you don't have to go back and forward with your customer to find the root cause for a problem, but you can just debug with mixed and view all this information. So it's just wait for Studio to parse the dump file. Now it's bigger, of course, so parsing takes a bit longer. And after this, we can see all the locals as well. And that's pretty interesting. Let's go back in our call stack for a few steps. Here's the call stack, and we go to the button click, for example. And in locals, you get the reference to the complete form. You can browse everything. You have everything in memory, as it was on your client's machine when the application crashed. We always have to keep this in mind. That's not in here. It's always easy to not really realize the power of this, because I'm running it on the same machine and everything's okay. But the use case is you're creating the dump file on your customer's machine where you don't have Visual Studio, where you actually don't have access to the machine. Get this dump file and you view it on your machine. That's the important thing. Okay. So what else did I want to show you? There are a number of additional tools which I use during debugging. I won't show you them, but they're just so that you have heard about those. These are tools which are essential for me, and I would not do a single debugging session without those tools. There is Debug View. It used to be sysinternals, now Microsoft. You can download this, install it in your machine. It's something like 80 kilobytes in size, and it shows you all these trace.writelines or debug.writeline statements which you've written in your application, but it shows you even if you don't run the application in a debugger. So you can just show the output of all the debug writelines. Bear tail is if you're running, if you have some kind of Unix or Linux background, you know what tail does. Tail follows a log file, or tail can follow a file while this file is still being written. And bear tail does the same thing. It does multi-tapped interface to follow a number of log files. Reflector Pro, that's a commercial tool now. I think most of you know Reflector. Who knows Reflector? This has to be nearly 100%. I'm not going to do the opposite, because this would be this would be too telling. If you don't know Reflector, if you would have raised your hand now, then you should not tell too many people about this. Instead, you should go out, download Reflector. The company providing Reflector decided to make this product, which used to be free for 9 years. They decided to make it commercial, And 2 months later, they got so much bad feedback that they decided just 2 days ago to make it free again. So that's fine, but only the current version is free. So current version is version 6.8. You can go there. You can. It's Redgate. You can download this product, and I don't know. Version 7 costs about $30 or something. So it's not massive. But if the pure fact that it was free for 9 years caused a lot of uproar, of course. Okay, Reflector allows you to decompile this. Now, Reflector Pro hooks into Visual Studio. It costs, I don't know, something like $160 or something. So it's also not massively expensive, but it allows you to use the magic of Reflector, but use it during debugging. So you can step into decompiled code. That's, for me, again, that's a massive feature. I do a lot of debugging on code which is not mine, or on binaries for which I don't have source code, and Reflector generates synthetic source code for me. It's not real source code, of course, it's just decompilation. LinkPad is something I need on a day-to-day basis to compile small .NET snippets and try out. LinkPad has a nice feature where you can call .dump on any variable, and it shows you in a graphical way how all the contents look like. And then there is one thing which is extremely important for me, and that's an attached to process macro. You'll find this on my weblog as well. I put this online a few months ago when I did this session. The reason for this macro is that I generally like to, I don't know if I have it on this machine. That's not my regular machine, it's a new machine. I just got it quite recently. Normally what I do is, when I create a web application, I don't run an ASP application, for example. I don't usually run it using F8 inside of the Visual Studio development or test server, Cassini, this ASP hosting process which starts up. I usually run my applications directly inside of IIS. Now, I write a lot of JavaScript code these days. I write a lot of HTML5 code. And of course, there is some server-side code as well, no questions about this. And I don't want to recompile my projects most of the time, so I just want to attach. And this allows me to attach to a process. That's a small macro which you can put at a button click event to attach you to w3wp.exe, for example, which would attach you to IIS, or attach to Internet Explorer if you want to do JavaScript debugging or things like these. And then you can attach and detach without really restarting your application the whole time. It's just a lot faster. It saves me a lot of time. Okay, let's see, what else do I have here? So there's this one point in the middle, which I tend to keep as some kind of an extra, depending on how much time we have left. And today, even though we had this nice interim experiment regarding debugger visualizers, we still have some time left for this one. And that's something which is, it's not, at first glance, it's not really debugging. And I'm saying a number of things here which might be obvious for 80% of you. That's important here. The rest, I try to be non-obvious for 80%, but now I'm saying something which most of you might think is obvious. I've been saying this for about 10 years, and I continue to say this because it's so important. The reason I'm saying this is because I see a lot of different applications. That's my kind of work. The work I do is review architectures, talk with architects, try to find problems, debug applications, etc. And there is one key cause for most of the pain we see in applications. Well, if it's technical pain. Most pain we see is project-based or organizational pain. We can't do anything about this. Not at this conference here. Okay, but if you have technical pain, if you really look at technical pain points, my number one pain point is exception handling. And I'm only going to spend 5 minutes with this, but this is tremendously important. Now, if you have a class customer manager, for example, let's just go into a sample here. And this has a method store customer. Store customer. Customer cust. Okay. And what store customer does is it goes there and does an insert statement into a database or an update or whatever. Then the question is, how do you handle exceptions for this class or for this method? Let's say in some other class in a client we have a public void button save click and pseudocode. I'm doing partly pseudocode here, which calls customer manager dot store customer current customer, something like this. And It really is about debugging. It's not about a debugging feature, but it is about the essence of debugging. And the essence of debugging is finding the problem. Okay, how do we call this? Let's say in here we open a SQL connection, we open a SQL command, we execute this command, or we use the entity framework to store some data. Now, what I see quite a bit is well, actually the interesting question, let's go one step backward because that's really important. Let's see, what is the return type of store customer? This has changed a lot in the last 10 years. Today, most people would agree that store customer returns void. And if it doesn't, then, well, if you can't store the customer, it throws an exception. We see this quite a bit. Sometimes we see this. So the problem is, and that's number one, if you debug source code, you need to understand this exception contract. And there is an exception contract which is implicit. And the question is always, when do you throw an exception? That's been a question in Java for years, in .NET for 12 years now. When do you throw an exception? And one of the key answers in the past was, well, in an exceptional condition. Thank you very much. What is an exceptional condition? Well, that's a bit spongy, the whole thing. And the problem is, if you have 30 developers on your team, they have 30 different definitions of what an exceptional condition is. Store customer, let's say if I store my customer in a database, in a SQL database, is it an exceptional condition when the database is not available? Yes, that's definitely. Most people would agree that's an exceptional condition. If you write JavaScript code on a web client or on a mobile phone application, let's just say you write a mobile application Windows Phone 7 app. You have a method store customer which has to go to a server to store the customer. Well, given that you're running on a GPRS network, the fact that you can't reach the server might not be very exceptional. This might be very common, actually. So does this method throw an exception now? Well, and then we have to ask ourselves, should it matter if the same code is running on, in terms of the exception contract, should it matter if the same code is running on a phone or on a Windows machine? And I think it shouldn't. So the exception contract, the implicit contract, most people on the .NET framework assume today is very simple. We don't throw an exception in exceptional conditions. Instead, we throw an exception whenever the method cannot do what the method name lets us imply. And that's very easy. That's the only rule you need to follow. And this makes your debugging life so much easier because an exception is your main entry point in debugging. If the method cannot do what the method name lets me think it does, then it throws an exception. Okay, but what in our case, in the phone case, when we know that things go wrong quite often and we want to return some kind of status code or whatever, in this case, just rename your method. Try store customer. That's the accepted pattern. The accepted try pattern is to return a Boolean, and if you have output variables, return the odd, or have output values, return the odd values using odd parameters. But that's not the essence. The essence is that you're changing the name so that I know as the caller of this method that I need to check the return value. Otherwise, if I call store customer like this, what's going to happen, and that's what turns this whole thing into a debugging problem, is you know that this is a Boolean return type, but some of your co-developers, 5 years after you left the company, they forget about this, and they will just call it. And you're not making this explicit, that they have to check the return type. If you rename your method, try store customer, you make this explicit. And now I know that you're not following the standard exception protocol, which the rest of the .NET framework follows, but for this particular method, you're doing a different protocol. And that's the first step in debugging. I need to understand your protocol. And then in exception management, there's one thing which kills you in debugging, and that's why I'm mentioning it, because I'm seeing this, and I'm not lying. In 100% of all applications which I review, I see this in at least one point, and it is just wrong. So you do something like logger.log ex, throw ex. That's wrong. You never want to throw ex. The rethrow command in C# is throw, not throw ex. And this is what causes a lot of pain in debugging, because if you do a throw ex here to rethrow the exception, you're not rethrowing this exception, you're creating a new exception. So if you look at the call stack, or let's say if I do a try-catch here, somewhere else, and I look at the call stack here, then my call stack would point to this line. it would not point to the insert statement which failed. It would contain an incorrect call stack if you do a throw EX. You only do a throw in 99.9% of all cases, you want throw. If you've written throw EX, you didn't mean it. If you are working with developers who are junior developers, please review your code base. Create a regular expression, find in files in Visual Studio, Ctrl-Shift-F, use a regular expression to look for all throw, EX, or similar statements. To all throws which contain something which does not start with new for new exception or something like this. And you will find this in your code, and it is wrong. And if you have this in debugging, it will make your life extremely hard. Okay, I was digressing a bit, but that's an important topic in debugging. Okay, so with this, we've reached the end of the session. Well, it was great that you have stayed with me during my 5 minutes of shame, or was it 10? It might have been 10. It felt like an hour of shame, at least. I think it wasn't an hour, but it felt this way. What I will do is I will try to find out what the problem was, and well, I think it was this. I know that it was the wrong version because this was a version 9 DLL. You have to reference a version 10 DLL. This is Visual Studio version specific. I should have realized this earlier. I don't know why I didn't. So it was great that you've been around with me, and I would have deserved that half of you would have left the room in the meantime, which you would have done if I would have been a new speaker, etc. So I really appreciate this here. Thank you very much. So I hope that you still enjoyed the session and that the information was interesting. We only lost about 5 minutes out of the whole session with this, and I think that some of the debugging features in Visual Studio are currently underused. One of them are the trace points in Visual Studio breakpoints. But I think the most powerful feature you have in Visual Studio 2010 today is actually the ability to create a crash dump on your client's machine, to have your client send the crash dump to you, open it inside of your instance of Visual Studio, and find out what their problem was, even though you don't have access to their machine. That's massive. You can build your application around this. You can download the source file, which shows you how to call this API. And you need a DLL called debughelp.dll. You can ship this with your application. It's from Microsoft, and this will allow you to create dump files which you can then later analyze on your machine. And of course, if you use Visual Studio Ultimate today or the test edition, then you should really look into IntelliTrace. IntelliTrace is pure magic during testing, because as you've seen, it allows you to follow all the steps which your tester did to reach a certain error condition. Okay, and with this, I'd like to thank you for being here. Thank you for bearing with me through this 5 minutes. I hope that you will welcome me, nevertheless, next year here in Belgium. And it was great to have you here. Thank you very much.